Today we're going to learn how to find the sum of consecutive terms in an arithmetic series by using the following two formulas. Let's go and see. Today we are going to learn how to calculate the sum of a certain amount of terms in an arithmetic series. Now here is the arithmetic series and it consists of only 5 terms. Now it's quite easy to calculate the sum of these. We just simply say 2 plus 5 plus 8 plus 11 plus 14, which gives us an answer of, yes, you're right, 40. So this 40 is the sum of this arithmetic series. Now it's quite easy to calculate the sum of only 5 terms. But what if there's 100 terms? We cannot simply spend the time to add them individually. So we are going to learn a couple of formulas that can help us with this challenge. We are going to make use of exactly the same arithmetic series as in the warm-up. So here is the first formula. There it is. So this means that the sum of a certain amount of terms is equal to that amount of terms divided by 2, and then in brackets we've got a plus l. Now this a basically means the first term or the term where we start adding up. So if we started at the first term, this a will be a 2. If we, for example, started at the third term, we only want to add those 3 together, this a will basically be an 8, okay? The L is the last term that we're going to add, so that will be 14. So in the place of L, it will have a 14, okay? So quite easy. So we simply do the substitution. In the place of n, we will put a 5 because there are 5 terms that we want to add. So in the place of this n, we also put a 5 and then divided by 2, and then in brackets we've got a, which is the 2, there it is, and in the place of the L, there's the 14. So if we do this on our calculator, we will simply see that the sum of the first 5 terms is equal to 40. As easy as that. Now, what if we don't have the last term? Okay, we know where we are starting to add up, so we know we have the first term, but we don't know where we will end. Okay, so just for simplicity's sake, so let's use a different formula. This is the sum of the certain amount of terms, if we know how many there are, is equal to n divided by 2. And then we have 2 times a. Now if we start at the first term, this a will be a 2. So there it is. Plus d, which is our constant difference. Now we know how to calculate the first constant difference of an arithmetic series, don't we? We just simply say 5 minus 2, which gives us a 3. Or we can simply say 8 minus 5 is also a 3. We've learned this in a previous lesson. So there we go. There's the first constant difference. And then we have n minus 1, where n again is 5. And if we do this entire calculation, we will get the sum of the first 5 terms, which is equal to 40. And that's it. So let's go and look at another example. In this example, we are given the sum of an arithmetic series, which is 40. We are also given term 1, which is a 2, and the last term, Tn, is equal to 14. So how many terms are in this series? We want to know what n is. So I can make use of this formula. There it is. Now why this one? Because we are given the first term as well as the last one. So in the place of Sn, we can put 40 because we know what the sum is. There we go. Is equal to n over 2. We still don't know what n is. That's what we want to calculate. In the place of a, we can put 2. And in the place of L, 14. There we go. So now we simply solve for n. So what we do is we take this 2 and we multiply with it on the other side because we're dividing here, right? So now we have 80 is equal to n times 16. So this 16 is the coefficient of this n. So we simply say 80 divided by 16 gives us 5. So we have 5 terms in this series. We added 5 terms to give us an answer of 40. There we go. Now what if we are not given the last term? We are given the first constant difference, which is equal to 3. How many terms are in the series? So basically we cannot make use of this formula. We have to use this one. There it is. So again, in the place of Sn, we put 40 is equal to n over 2. We want to calculate what n is, how many terms there are. And then 2 times a, in the place of a, we put term 1, which is a 2. There we go. Plus the first constant difference is given to us, which is a 3. There we go. And then n minus 1. Now we simply continue to solve for n. Now here we divide with a 2, so we will multiply with it on the other side with the 40, and that gives us 80. This is equal to n, which is now left on this side, and then we do the sum inside these brackets. So 2 times 2 is 4 plus, and then this first constant difference we are going to multiply it in with the distributive law, and there we go. So now we have plus 3n minus 3, and now we are left with the following. 80 equals n, and in brackets we have 3n plus 1. Now where does this 1 come from? 4 minus 3, that's the 1. And now we also do the distributive law again, which is with this n, we multiply it in. And now we have 80 equals 3n squared plus n. And now this is a quadratic equation, and with quadratic equations we move everything to the one side. That's why it looks like this. Now we are going to factorize with a trinomial factorization, and we are left with 0 equals 3n plus 16 in brackets and n minus 5 in brackets. This is a zero product rule, so we solve for n by equating each bracket to 0, right? So then we are left with n equals minus 16 over 3, or n equals 5. Now I assume that you already know how to do this from previous lessons and previous years of mathematics, and now we simply know that our n is equal to 5. It cannot be minus 16 over 3 because n can only be an element of natural numbers. And that is it for today. Good luck with the PDFs and see you next time. Bye.